Okay. Shoot, I should have reported all that. That's okay. So again, here's a factoring flow chart. We'll go through this as we do some examples.
Mm-hmm.
Here we go. Well, this is a little bit too advanced, but
Yeah, I don't. I mean,
let me do something that's a little bit more
Mhm.
reasonable. Hold on a sec. Factoring. You know what? I'm gonna kind of jump around among these different worksheets. So let's start with we'll start number 2. Now, what do you have in common between these two? What can they both be divided by?
4,
No, 9 and 36.
3.
Higher.
3. Well, 9.
9, exactly. Because 9 can be divided by 9, 36 can be divided by 9.
Wait, what goes 4 times 36? Yep.
Yeah, right. The thing about what are the factors of 9? 1 and 9, right?
Yeah.
What are factors of 36? 1, 2,
12,
3,
12, 12,
right,
4, 6,
4, 6,
36, 18.
9, 12,
Yeah.
18. Yeah,
Factor the same,
you gotta
too.
pick the highest of them all, which is 9. Right?
Yeah.
You have x plus 4.
Mhm.
Yeah, that's all. So that's going back to the flow chart, which we see right here. Are the common factors. Now, I'm trying to find another good one here we can do. Not that one. Not that one. Not that one. Here we go. That's what I was talking about. So took me like 5 times to finally get it. So you take out common factors and then something called the difference of two squares. Like, for example, let's look at number 5.
Yeah. Huh?
So what's common between 2 and 18?
Factors of 9.
No, 2 and 18. What factor they share in common?
9.
No, 9's not a factor of 2. What are factors of 2?
Oh, 2.
Right.
Yeah.
So you take a 2 out. When you take the 2 out, what's left inside?
18.
Take the 2 out.
Well,
So
x squared, x squared.
X squared and
18.
no, you gotta take the 2 out. You gotta divide by 2.
Oh, 9.
-9.
Yeah.
Okay. Well, let's try it one more time because I'm now a little concerned about factors because that's a 4th, 5th grade concept. Maybe that got lost in the shuffle during the
No, it's
pandemic.
not. No, it's not. I was just like,
Okay, 20 and 45. What factor do they have in common?
in the greatest common factor.
Greatest common factor 20 and 45. If it helps, just write them out and just circle it. I mean, if you have to, until you can move faster with it. But
is it 5?
it's 5. Good. Okay.
Yeah, that's what I'm like,
No worries. If you've got to write it out, I'm totally cool with that. It's just take longer, but I mean, whatever we can do to help you to be successful, that's what we'll do.
I haven't like used that term like since 5th grade.
No worries. It's all good. So yeah, you get this, right?
Yeah.
Or for number 5, I got 2, but we're not done yet. So something called the difference of two squares, a squared minus b squared. If the first and last terms are perfect squares and there's a minus in the middle, it can be broken down as a minus b times a plus b.
Yeah.
So in this case, I could break it down as x minus 3 and x plus 3. Or here I could break it down as 5, 2a minus 3, and 2a plus 3.
Yeah. Huh? Yeah, so wait. So for every single factor, are they always asking for the greatest common factor for every single one? Or how does that work?
Well, sorry, repeat that.
for like every single factor problem, do they always ask for the greatest common factor?
Well, you gotta look for it first. Always look for it.
Yeah.
Sometimes like there's not a greatest common factor for number one, for example. That's
Well,
just 3x minus 1, 3x plus 1.
huh?
Right? Because you're breaking apart 9x squared and breaking apart -1. So there you
Huh?
go.
Yeah.
That's all. Or here, 2n minus 7, 2n plus 7.
Yeah.
So what you do is you simply take the square roots of those. So that's one part of it.
Yeah.
I'm gonna close this down. We don't need that. We don't need that. Don't need that.
Um,
Okay. Close that. Okay. So now let's talk about when you have three terms.
yeah.
You still look for common factors if there are any. I don't know if this has, well, these do, like for example, 15 and 16, like 15, I could pull out 2. Or here I can factor out 5. But sometimes you need to break it down even further when you have three terms. So let me show how that happens. Like starting with number 1. Okay, b squared plus 8b plus 7.
Yeah.
So there's something called the I call it the diamond. What you do in general terms, a quadratic expression looks like this.
Uh-huh.
So ax squared plus bx plus c.
Oh, yeah.
So you put a times c up here
Uh-huh.
and b down here. So in this case, my a is 1, my c is 7, and my b is 8.
Yeah.
And what you want to do is you want to find two numbers that multiply to 7
Mhm.
and add to 8.
I don't know. I feel like I've used this like method before.
You may have, yeah. So 1 and 7 are two numbers or two factors of 7 that multiply 7 to add up to 8.
Yeah.
So then you just say, okay, easy, then you just say b plus 1 and b
Mhm.
plus 7. And now it's factored. Because the whole point is if you FOIL,
Mhm.
FOIL's like this. B1, B7. B times B is B squared. 7B, B, and 7. And when you combine the like terms, you do get AP in the middle.
Yeah.
So sometimes some people will do the box as well. Like for example, for number 2, what they'll do is they'll put n squared in here and 10. And you gotta find two numbers that multiply 10 add to -11. That'd be -n and -10n. Because those multiply to 10. And then you ask yourself, well, that's n and n. This has to be -1 because n times -1
Uh-huh.
is -n. And then this has to be -10. And then it all makes sense because you have -1, -10. And there you go. N minus 1 times n minus 10. Like same thing here. Like, if I do a box, I put n squared here
Mm-hmm.
and -12. I'll still do the diamonds, like I'll put -12 and 4 here. So two numbers that add up to 4 but multiply -12, that'd probably be -2 and 6.
Mhm.
That's n and n.
Ah.
So you're splitting 4n into two terms, -2n and 6n. N and n.
Mhm.
This has to be -2
Yeah.
because n times -2 is -2n. This has to be 6.
Mhm.
And you kind of check, yeah, -2 times 6.
Yeah.
So n minus 2.
So it's kind of like I use this in biology.
Yeah, kind of. Yeah, with genetics.
Yeah, that's what we're
The
doing.
Punnett squares, yeah.
Yeah, Punnett
Yeah,
square.
here's yet another one.
Um,
So so m squared,
huh?
-90. Two numbers that multiply to -90 but add to 1,
Yeah.
-9 and 10.
Mhm.
So it's m and m. That's -9. That's 10. To get -90. Yeah, that makes sense.
Mhm.
And there you go. M minus 9 times n plus 10. So Now, sometimes they get a little more complicated,
Mm-hmm.
like
Like what's
these
the
here.
example of that? Mm-hmm.
So this is when the leading term is not one, or leading coefficient is not one.
Mm-hmm.
Um, so I'll still do the same thing. 3p squared and -5.
Mm-hmm.
But then I have to find two numbers that multiply to this, -15,
Uh-huh.
and add a -2. Actually, that's p squared. So it'd be -5p and 3p.
Mm-hmm.
And then that probably has to be 3p and p, -5 and 1.
Uh-huh.
And there you go.
Okay.
That's it.
Mhm.
Um, I'll do it one more time. I do need to get going.
All right. Like where you have to go, or you like a meeting or something?
Yeah, I have another call I have to get to.
Oh, are you not home or?
No, I had because I was running a little behind schedule, so I had to stop at a Starbucks really quickly, and then I have to then hop on another call, then I have to go to someone's house after that.
Oh, okay. Yeah.
So here we got 2n squared
Oh.
and -9. You gotta find, oh, sorry. So you gotta find two numbers that multiply to -18n squared,
Uh-huh.
but
So
add
two
up to
and
3n.
everything. Yeah.
So what two numbers multiply -18, but add up to 3?
Oh. Wait, add up to, so can I use negatives then or no?
Yeah, yeah. So
Oh.
multiply -18, but adds up to 3.
Uh, wait, -18. I don't.
Six and -3.
Really? Okay. Oh yeah. Oh yeah. Because like okay, yeah, minus the 3 from the 6. Yeah.
So that's 2n and n. Actually, I probably should do the other way around.
Huh?
So that becomes 3
Yeah.
and -3, and there you go.
Sounds good. Yeah.
That's it.
No.
Yeah.
Yeah. All right.
So anyway, I'll stop the video.